Good morning.
Good morning.
How are you?
I'm doing good.
Good.
I'm tired.
Tired? Do you have a busy weekend?
Yes.
Do you enjoy your break?
Somewhat. I had to work.
Somewhat.
I had to work Monday, so
Okay.
and I had to work Saturday and all that stuff.
Yeah.
I also got a haircut, so
Well, awesome. Looks nice.
yeah.
Looks very good.
I'm glad I got it because trying to get your hair out of your face when you're trying to work,
Yeah.
especially getting buggies in the heat. Yeah. Well, during Monday, Saturday, and Thursday, actually Monday and Saturday,
Mm-hmm.
I had two other coworkers working with me, so not not
Okay.
not the exact same times,
Yeah.
but but Saturday I was the first one in, and then another coworker came in at 11, and
Oh,
then at
wow.
2 another one came in. So
Okay.
I have
Mhm.
there's four baggers,
Oh, yeah.
me, Fred, Nick, and the funny thing is there's another David that works there,
Okay.
but he's been working for Winn-Dixie for 20 years.
Oh, wow.
Not the
That's a
same
long time.
location, not the same location, but same location where I work it as. This
Uh-huh.
month is like his 16th year working there.
Oh, my
That same
goodness.
Winn Dixie. He's been there that long. He remembers like the main manager, my manager Jeff Shook, the main
Yeah.
manager, when he was an assistant manager there. He's been there that long. That
Oh, wow.
and he's just a bagger, which is this crazy thing because like you think he'd be like a manager or something, but he's not. He's a bagger just like me. But like
My goodness.
the thing is, like most of my coworkers, like not most of them, but a lot of them are black.
Oh, yeah.
Yeah, like most of the cashiers are black.
Hmm.
We have two black managers, and I have two black two. There's a bunch of people who work in like the different departments, like produce,
Yeah.
dairy, produce. Well, we have a few different. We have a bunch of different things at my store. We have produce, deli, meat, seafood. I mean, meat and seafood go together. We have the bakery, the dairy, and we have a pharmacy.
Okay.
We have a lot.
Let's see. I'm trying to get Victoria said she's having trouble, so I'm trying to get the link resent to her. Let's see if this will work.
I mean, my mom is sending you a picture of like stuff because like scanning stuff has kind of been a little bit problematic for us
Uh-huh.
because a lot of times the printer just said, "Nope,
Just
not gonna
not.
work today. Not gonna work today."
Yeah.
And that today turns to basically every day.
Oh yeah. Well, that's what sometimes mine will just decide it's not gonna link up. It just won't.
I mean, after we have like a troubleshooting program for that
Uh-huh.
printer, so, but it works after we do that.
Oh, good.
But like this is my biggest model I have.
Oh,
Biggest
wow.
big. This is my biggest 1 to 400 model.
Okay, that's cool. Wow.
Here's my here's my here's my one more recent ones. Here's my smallest one.
Oh, wow.
Delta MD88. Unfortunately, these are retired now. Real life, sadly. I love the 80s
Uh-huh.
because like I've only flown in basically only flown at MD80s for Delta. So
Oh, okay.
I've also been to the cockpit of one.
Oh, cool.
Here's the two things of the cockpit: cramped and
Oh, yeah.
complicated.
Oh, I bet.
No, like there's only room for two people in there.
Oh,
Nobody
wow.
else. I mean, like when like the pilot let me sit in the seat,
Uh-huh.
he had to step like into like the door. It was that cramped, so
Oh, wow.
it was actually quite nice
Oh,
to
cool. All righty. So we'll go ahead and get started. We're shifting gears a little bit today. So we worked with English for a good long while. And so hopefully you've had a chance to not only practice with English questions, but also going through and looking at what you missed and why you missed it and being able to determine kind of, are there skills that you need to review? We talked about a lot of different grammatical skills. We talked about a lot of punctuation skills, things like that. So there may be some rules that you need to go back and brush up on before you take your test to make sure that you are ready for everything. And so now we're shifting gears and moving on to math. Okay. And so the ACT math is made up of 60 multiple choice questions to be answered in 60 minutes. So obviously, if you just do the math on that, you can say, hey, that gives me about a minute per item. One of the things that I want to mention, though, and this is, let's see, let me get. One of the things to think about, though, is that you're going to be able to answer some a lot more quickly than a minute. And then there's going to be some that may take you a little over a minute. But that just kind of gives you a good gauge that, hey, when I'm halfway through the test, if I'm on number 30, I want to make sure that I've got at least 30 minutes left, if not longer. The other thing is, just like with English, remember we talked about how if you get stuck on something and you're not sure what it is, just use your letter of the day and move on. Okay, so don't get stuck. Okay, don't waste your time on something that you do not know how to do. And that's going to be one of the things about math that's going to be a little different than English. All of the English skills, all of the grammar rules, all of the punctuation rules, things like that, those are all things that you've been taught. Math is going to depend on where you are right now. Okay, so if you haven't taken geometry and you go take the ACT, well, guess what? You're going to be missing geometry questions, and probably you're going to struggle on anything that deals with algebra 2 type skills, trigonometry skills, things like that. So basically, your amount of learning at this point is dependent on what classes you have taken by the time you take the ACT. So one of the things to notice here is that it is testing up to the beginning of 12th grade. So there are things on there that maybe you haven't seen before. There may be things that you haven't taken yet. Okay. So again, remembering that the ACT is scored on a 1 to 36 scale. Okay. And so unless you're just looking for a perfect 36, then you know that there are going to be some things on there that you haven't seen before, because more than likely you haven't taken the maths. For Alabama, our required maths to graduate are Algebra 1, Geometry, and Algebra 2. Like I said, a lot of times Algebra 2 is going to address some trigonometry, and basically when I say trigonometry, that's dealing with triangles. Okay, so it's going to be rules dealing with triangles. So some trig you're seeing in geometry, some of it you're seeing in Algebra 2. And so anyway, there's going to be some things that maybe, if especially if you're a junior, you're not going to have seen all of this math yet. Okay. So just know that there may be some things on there that you go, oh my goodness, I don't have a clue. Well, guess what? If you don't have a clue, guess and move on. Okay. Don't waste your time trying to figure out something that you do not know how to do. Again, the instructions are on the test. The instructions are the same on your practice test that you're using as the real test. So know the directions now. Don't waste time reading them on the test. Okay. Calculators are permitted on the ACT math test. You may use a calculator on this test for any question you choose. However, some questions may be better solved without a calculator. There may be something that it will take you less time to do in your brain than it would be to punch it into the calculator. Okay. So you don't want to do every single problem. You don't want to try to use the calculator for all of it, because there may be some that you can do faster without it. You want to make sure that the calculator you use is one that you're familiar with and that you have used before. I know a lot of you guys in Algebra 1, pre-algebra, the Texas Instruments, the TI, the TI-30X2S is going to be an approved calculator. This is like a $10 calculator that you can get on Amazon, get at Walmart, get anywhere, and it's going to be pretty user-friendly. But again, you don't want to go into the ACT never having used it. Okay, you need to be familiar with how to use it, and we'll kind of work through some of these things. If you have one of these and you want to practice with it as we're going through practice, we can do that. just know that there are some calculators that are approved and some that are not. Really quick, I'm going to shift over to that page, the ACT calculator policy. In our paperwork, we have this address that you can go to. You can see that this policy was last updated August 5th of 2019. I'm not sure how often, I mean, obviously you can tell that they don't update it all the time, but but you always want to check just to make sure. If you've got a different kind of calculator, you want to be sure to look at these and know which ones are allowed and which ones are prohibited. Okay. Graphing calculators are not going to be allowed. Remember, we talked about you can't have a smartphone, you can't have a watch, things like that. You can't use those things as calculators. Okay. So anyway, these are kind of things for you to be able to know what you can have, what you can't have. Okay. All right. And I emailed you guys this paper as well, and you can always check on the website. All right. Victoria, are you good? Are y'all good, Victoria? You can give me a thumbs up if you're okay. I just want to make sure. I don't want to go on without you if you're not. Are y'all hearing me okay?
I can hear you just fine.
Okay. Victoria, can you hear me?
From the looks of it, like... Oh.
Victoria, can you hear me?
She's muted.
Okay, cool.
Now I can.
Okay, good. Well, that's what I didn't want to go on too much without you, because I could tell that obviously there was a problem. So I'm glad you can hear me now.
Yeah, we just had to fix it for a second.
Okay, well, what I was talking about is the calculator policy. I emailed you guys this page. You can also look on the notes that we'll go back to in just a minute is the website that you can always go and check and see. I was talking about the TI-30X2S, whatever calculator is going to be one of the easiest to deal with. More than likely, this is something that you would have used in either Algebra 1 or Geometry, and so it is an approved calculator. The other good thing about it is it is solar. So one of the things about calculators, if you take a calculator that requires batteries, you either want to have just changed the batteries in it, or you want to take battery backup. That would stink if you got to the test and your batteries died and you couldn't use your calculator.
That would suck, since you can't
It would
use any electronic devices besides a calculator there.
So when I was taking my ACT prep classes, when I was doing my training stuff, I just saw the termite guy pull up. I don't know if he's going to have to come in. Hang on just a minute. Let me go yell for my husband so he can come down and deal with the termite man. Let's see, where am I? Let me mute my screen so I can yell.
This is awkward.
Just a little bit.
How was y'all's weekend?
Stressful?
Oh, you think yours was stressful? I had to work Saturday and Monday.
Okay, maybe not as stressful as yours.
Yeah. And the thing is, on Saturday I worked 10 to 5.
Oof.
Actually, no, that was Monday. Saturday I worked 8 to 4, so...
Dang.
Yeah. But the good thing is I had 2 other co-workers there with me. Not the same time, but they came in throughout the day.
Yeah.
And the good thing, because the buggies, or shopping carts, ran out fully, even with 3 baggers. Because we get the buggies. Like, it was that busy with 3 baggers, it was, like, gone. All from
Dang.
gone. Okay, there she is.
Sorry about that.
Okay. We were just talking about our weekend.
Awesome. So I don't know if he'll end up ringing the doorbell or what, but anyway. Okay, so calculator policy, again, just make sure that you have one that's approved, have extra batteries if you need it. check your list before you go, just to double check and make sure there haven't been any changes. But like I said, with the calculator, you don't want to try to work every single problem with the calculator, because there are going to be some that you can do faster in your head than you can actually do. Or if you just doodle on your paper, if you just do a quick little calculation writing it, it may be faster than actually punching in the numbers on the calculator, or the functions and things like that. So you just always want to, use it when you need it. I was getting ready to tell y'all that when I last year when I was taking the ACT training classes, there was this guy, and he is a total math whiz. He finished his math test in 30 minutes, because we had to take the ACT as the beginning training part of our classes. So the first thing we had to do was take the ACT math for the math class. And I remember, like, this guy, he did it in 30 minutes, did not use a calculator on anything, and he's like uber smart. And so anyway, our class people, we kept in touch, and we still keep in touch. And so he did so well on it that ACT actually asked him to come start teaching the training classes, because he did so well. Anyway,
Wow.
not my ability. That's not my thing. But so anyway, that's the kind of person that's making Millie. No, sorry. That's the kind of person that's making the 36 on the ACT. But again, it's the kind of thing where kind of thinking through, Millie, hush, come here. Kind of thinking through, the different things, and looking to say reasonably, what can I answer really quick on my own? What am I going to need to use my calculator for? And which ones am I not going to, be able to do? So I'm just going to guess and move on. All right, I'm going to go back to our packet. And so, like I said, that you can see the web address where you can look to make sure your calculators are good. Millie, come here.
Okay. Also, I have a question.
What's that?
What package the like the AC is in any of the packets that you've given us? Is there a page with the ACT like grading thing, or is it just in the book?
What do you mean as far as the grading?
Like the sheet where you can see like the grading sheet for the
Okay, yes,
test.
Those are all in the red book.
Okay.
And they adjust them slightly per test. So each test, the numbers are going to be a little bit different. In a minute, we're going to talk about the math, though. I've pulled some numbers for math specifically based on 3 different tests.
Okay.
So we'll kind of look at that in just a minute.
Okay, thank you.
There's a note on here that says, unless otherwise stated, you can assume that figures are not necessarily drawn to scale. What that means is, unless there's that little 90-degree box drawn in a symbol, even if it looks like it's 90 degrees, don't just assume that it's 90 degrees, okay? So just note, although a lot of times they probably are drawn to scale, you can't assume that they are, okay? Geometric figures are going to be 2-dimensional. Whenever they say the word line, you can understand that it's talking about a straight line, okay? And if you see the word average, it means the arithmetic mean. So remember, like when you did mean, median, and mode, where you would take your set of data and you would find, so, it's talking about the mean and average are going to be the same thing, okay? So if it says average, then add them up, divide by the number of things you added together to get the average, okay? So now we're going to go ahead and take a look at some of those scales, okay? So ACT math scoring. The scoring report for ACT math is reported in 9 separate scores. You're going to have a total test score, and then you're going to have 8 other categories. The first category is called integrating essential skills. We're going to do a breakdown of that in just a minute, where we look at, okay, what in the whole wide world does that mean? But you can see that a good many questions, 40 to 43% of the test, is this information. Same thing with preparing for higher math, 34 to 36 questions, which is roughly 57 to 60% of the test. So you can see those first 2 things are going to be in a good majority of the test. The next thing we have is number and quantity, and number and quantity is going to involve algebra, functions, geometry, statistics, all that good stuff. And then you can see modeling is going to be less than 16 questions, less than or equal to 16 questions, which is going to be less than or equal to about 27%. And I forgot my percent sign there. So you can see kind of how, you know, what of these things are going to be the biggest majority of the test. So it says integrating essential skills. This category measures your ability to apply your understanding and skills to solve more complex problems. These problems, the problems involve combining skills in multiple steps to show your understanding of conceptual connections while demonstrating skill fluency. So what this is saying is that you may be using several different skills to solve one problem. So they're looking at, do you know what skills to use together to answer something? Skills used to assess this category might be rates and percentages, proportional relationships, area, surface area, volume, average and median, the expression of numbers in various forms. The next one is preparing for higher math, and this one is broken into 5 reporting categories: number and quantity, algebra, functions, geometry, statistics, and probability. Okay, so number and quantity. This category addresses real and complex number systems, your understanding of the 4 basic operations: addition, subtraction, multiplication, division, properties of real number systems, working with rational and irrational numbers, integer exponents, vectors, and matrices that are treated as number systems will also be addressed. I don't know about you guys, but vectors and matrices, I heard those words and I was kind of like, oh my goodness, I don't know those. I think that was something probably that I learned in Algebra 2, but it's been quite a long while since I have really dealt with them. But the good news is I'm going to show you some notes on them, and I think that once you see it, you'll be like, oh, that's no big deal. I can do that. Okay. Algebra. This category will assess your ability to interpret and use various equations based on linear, polynomial, radical, and exponential relationships in the context of equations and inequalities. Okay, so think about, you might see some inequalities on here. You will need to know how to solve, graph, and model different types of expressions to strategically solve problems. Functions. This category will assess your ability to interpret the characteristics of a function in the context of a problem, your ability to manipulate and translate functions, and interpret and use key features of a graph. Geometry. This category will assess your ability to apply your knowledge of shapes and solids to spatial concepts that include congruence and similarity. I guess I should change that to similar relationships, and surface area and volume measurements. You will apply your understanding of geometric objects to model and solve problems, as well as find missing values. And I have as well as, again, so obviously I did not do very well with my grammar in doing this, as well as apply concepts to a coordinate plane. Trigonometric concepts of right and non-right triangles will also be addressed. Statistics and probability. This category will assess your ability to use data to assess the distribution of data, assess data collection methods, and calculate probabilities. And then modeling. This category has questions that involve producing, interpreting, understanding, evaluating, and improving models that represent complex math problems. So basically what we're going to be doing today is we're going to be talking about the test in general, some strategies, some things like that. And then we are only going to be covering our I think number and quantity is where we're going to get to today. All righty, so get ready for the test. The first thing is practice, practice, practice. The more familiar you are with the types of questions that are asked, the easier it will be when you're actually sitting down to take the test. It says practice with authentic ACT material. After scoring your practice test or test, you want to identify your mistakes, just like you did with the English. Identify your mistakes. Every mistake you make on the test happens for a reason. If you don't understand exactly why you missed it, you will make that mistake over and over again. So again, I have in here in a notebook, write down the gist of the question, why you missed it, and what you'll do to avoid missing it in the future. Have separate sections so you can separate them by subject. or by subtopic. So like if it's number theory, is it fractions? If it's algebra, is it solving equations? What is it specifically that you're having trouble with? And then review the skills that you've missed. If you can't remember how to do something or you've not previously learned that skill, you might need to consider one-on-one tutoring or teaching to fill in those skill gaps. Okay, again, this is going to be based on what you're trying to get as a score, and we'll get there in a minute. Okay, again, understanding your weakness in the math test. Are you running out of time and not having time to finish? And is it because is it a timing issue, or is it because you don't know the content? So that's what practice tests are going to show you. Do you need to brush up on the material, or do you need to practice with speeding up while you're working? And it says every student has different flaws. Some students aren't comfortable with the material, while others know the material well, but they just can't get it done quick enough in the 60-minute time limit. As with the English test, here's how you can figure out which one applies to you. Take only the math section of the practice test. For the section, use a timer for 60 minutes. If time runs out and you're not done, keep working as long as you need, but you need to mark it as, you know, where you've got to during that time period. Score it and see what your score would be within the 60-minute time period. Score it and see what your time would be in your total time period, and look for the discrepancy there. If your score is about the same with both timing, then you know it's a timing issue. If you did, then you know it's a content issue. If you did a whole lot better on your open-ended time versus your time, then you know it's a content, and then you know it's a timing issue, and that it's not the content, that you know how to work the content. You just need to learn how to work faster. Okay? So that's the realistic score versus the extra time score will help you to determine what you need to work on. So again, it's the kind of thing where you can start working on, even if it's a 60-second timer per question, you can set a 60-second timer and do one question and just start getting used to doing them in that time period. Or say I'm going to do 15 questions in 15 minutes. Set your timer, do 15 questions, and try to make sure that you're getting them done in that time period. Again, save some time with your bubbling. Okay, solve your questions first in the book. Write in the book. Okay, scribble in the book. That's your scratch paper. You're not allowed to have additional white scratch paper or lined paper or anything like that. Your scratch paper is the book. So what I want you to do is, if you need to write a problem out, if you need to mark something down, if you're eliminating answers, scratch them out in the booklet, and then circle your answer that you've chosen. Circle your answers in the book, and then before you turn the page, transfer your answers to your bubble sheet. Okay, again, a lot of the things I read say, hey, wait and bubble at the very end, but if you have a timing issue and you run out of time, that is not a good strategy, because you can get left with not putting answers in and time is up and it's too bad, so sad. Okay, so my recommendation is bubble your answers before you turn the page. Circle your answers in the book, transfer before you turn the page, and then move on. All right, some tips for taking ACT math. First, read and understand the question. Make sure you know what the question is asking you to do. The last thing you want to do is spend time doing something and realize you misunderstood the question and you've worked something and then you've got to redo it, okay? If the problem requires 3 steps to reach a solution and you only completed 2 of the steps, a lot of times they're going to use partial answers, or they're going to put some of the answers that you may arrive at as a non-answer choice or as a wrong answer. So like if you did 2 of the 3 steps, whatever that answer is for your 2 step, they'll probably put that as a possible answer choice. And so if you didn't complete it, you go, oh, look, there's my answer. You circle it and move on, only to find out you didn't do the whole entire problem. Therefore, that was the wrong answer. Okay, so that's a lot of times people say, oh, ACT is being tricky. They're trying to trick you. No, they're just putting something in there that could potentially be something that you would arrive at as your answer, but they're looking to see, did you complete the problem? Don't quit early. Reason your way through the problem so it makes sense. And a lot of times you may want to look back real quick just to make sure, did I answer the question? Did I do what they asked me to do? Pay attention to words like always, not, and cannot. Okay, so think about if it says it is always something, then you know that you're looking for the answer that would always be something. If it says not, then chances are they are going to put an answer on there that would be is, okay, that is something, or is the opposite of the not or cannot. Easiest to hard questions. The ACT math is structured such that the first 30 problems are less difficult than the last 30 problems. So knowing this can help you when you're looking at your goal score. If you're looking to score 20 or less in math, then you can spend more time on the first 30. You need to get at least 30 items correct, and then you can guess on, you're looking at being able to guess on 30 other ones, or not spend as much time on the additional 30. Okay, so all of these scores came from that back part of the book that has those scores, the scaled scores for each of the practice tests. So each practice test in the red book has a scaled score. What I did is I looked at like 3 or 4 of them. I looked at 4 of them, and these numbers were consistent all the way across. So to get like a 20 or less, you're looking at getting at least 30, at least half of the questions correct. Okay. If you're trying to go with a 27, you're wanting to get 45 questions correct. So that tells you that between a 20 and a 27, you're getting anywhere from 30 to 45 questions correct. If you're looking to score higher than 27, then you need to get more than 45. You're trying to get 45 to 60 items correct. Okay, so if you want to pinpoint yours a little bit more, go to those pages in the back of the book that has those tables set up. But this just kind of gives you an idea. Okay, so if your goal is only to hit a 20, then you know that you only need to get half of them correct. If your goal is to get a 27 or less, then you're going 45 or less correct. Okay, and so then that kind of gives you an idea that, hey, I've already guessed on 10 of them. I can only guess on like 5 more, but I really need to try to really work on the first, knowing answers correctly for 45 of the 60 questions. Again, if that's what your goal is around, a 27, 25, 20, somewhere around there, then you can say, hey, I know that I'm going to spend a majority of my time on 45 questions. Therefore, I'm going to guess on 15. That gives you a mindset and a strategy going in instead of going, I've got to get all 60. Unless you want a 36, you don't have to get all 60, okay? Solve the problem. Use the blank area of your test booklet to work out the problems. If you're not sure how to work a problem, or if your answer doesn't match one of the answer choices, we're going to have some strategies to use for what to do in that situation, okay? One of the first things is use your answer choices as a guide, okay? So look at the answer choices and say, okay, I know that my answer might be in fraction form. If every answer is listed as a fraction, then you know that your answer should come out as a fraction. If it's a decimal, you're working with a decimal. One of the other things that we'll talk about a little bit more in a minute is that usually the answers are listed in order from least to greatest. So if A is 1, B is 2, C is 3, and D is 4, and E is 5. Now notice there are 5 answer choices in math. But usually they're going to be listed in order from least to greatest. So if you end up coming out with an answer, you can kind of look and see where it falls on the least to greatest scale. Again, same thing with the English content, where 25%, actually it's going to be 20% on the math test, since there are 5 answer choices. Remember, there's going to be A, B, C, D, E on my odd number problems. Even number problems will be, what did I say, E, A, B, C, D, E. You'll have G, H, J, K, L. Is that right? I need to grab my book and look at that. So so you can see how just remember that your odd numbers will be the A, B, C, D, E, I mean, A, B, C, D, I think it's A, B, C, D, F. Anyway, we'll have to look at this in just a minute. But again, solve the problems. If you're not sure what to do, look at your answer choices and see if that kind of gives you a clue on how to proceed. The next one is translating words into math. If it is a word problem or if it has things written out, you need to look at your symbols or know your symbols to translate to be able to write it as an equation. Remember that if it says of, that means to multiply. If it says, you know, what is 2/3 of 15? You know you're going to be multiplying 2/3 times 15. So thinking about using those words that translate into mathematical symbols and things like that. Know your properties and formulas. We are going to have a concise list of properties and formulas that you need to know on test day. Number property rules include odds and evens, prime numbers, order of operations. Those are all things you need to know. Properties such as commutative property of multiplication, knowing that if you have A and B, and that you multiply A times B, that's the same as B times A. Knowing commutative means that I can add in any order. Noting that the distributive property, that I have to distribute a number outside of parentheses to every single term inside parentheses. And like I said, we're going to keep working with formulas, and we will, that should be 2 words right there. We will look at each category individually, and we're going to come up with a concise list of properties. Okay. Think before computing. This is the part where it says don't do everything in the calculator. Okay. Don't take the time. It's going to take you much more time to use a calculator on everything than it is for you just to think and answer a question quickly. So it says most of the calculations are fairly simple and actually will not require the use of a calculator, okay? If you do use a calculator, be sure you have a good idea of what your answer should look like ahead of time. So that way, if what you come up with on your calculator doesn't look like any of the answers, you know, you gotta do it again. All right, answer order and trying answers. So again, ACT Math has 5 possible answer choices. Answers are typically ordered from least to greatest. Because of this, a good strategy, if you're not sure what to do, what this strategy says is to try and answer. Okay, so I've got 5 answer questions, A, B, C, D, E. They're in order from least to greatest. So what you're going to do is you're going to start with answer choice C. Use answer choice C to plug it into the problem and see if it makes a correct answer. If it's correct, yay, you know your answer is C and you move on. But if it's incorrect, then you can look and see, well, was your answer too high? So then you would back down to either A or B. Or was it too low and you need to look at answers D and E? So that way, by starting with C, you're able to plug in an answer and then go from there. And then you can adjust whether it's too high or too low. You know, you're going to have to look at the lower answers or the lower value answers, or look at the higher value answers. Does that make sense? Did I explain that? Do you see what I'm saying about that? That if I started with C and it was too much, then I would back down to A and B. If it's too high, then if it's too little, then I would need to look at D and E. So I put an example of this in here. Oh, and here I put the letters about A and H correspond, B and G. Nope, that's wrong because I have C and H. I messed up on that. So A, B, C, D, E, G, H. I'm gonna have to look at that in just a minute and I'll fix that. Hold on just a minute. Let me grab my book. I don't know why I don't have it over here. Okay, let me. Okay. A and F correspond. So that needs to be an F. A and F. A will be my odd number problems. So A, B, C, D, E are going to be my odd number problems. My even problems are going to be F, G, H, J, and K. They skip the letter I. Okay. So odds, A, B, C, D, E. Evens are F, G, H, J, and K. All right, so in this example that I put on here, it says, which of the following ordered pairs in the standard XY coordinate plane satisfies the system of inequalities below? Remember, a system is just going to be where I've got more than one thing going on. So it shows that I have to find something where X is greater than 2, Y is greater than 0, and X plus Y is less than 5. So again, in this situation, I could just start here and let's plug in the values of letter C. So I plug in 3 and 1. Remember that these are ordered pairs X, Y. So 3 is my value of X. So I plug that in as 3 is greater than 2. Y is 1, so I plug in 1 is greater than 0. And then 3 plus 1 is less than 5. In that situation, I found that they were all true, so I know that C is my answer. I would circle it and move on. If I found that this made a true statement, and I found that 3 is greater than 2, then I know that, hey, I can focus in and try this answer next because 3 made a true statement. Or if it did not make a true statement, I know that that means I could eliminate all the ones where X is equal to 3, okay? So trying your answers means plugging them in. Obviously, you want to work as quickly as you can, testing out the values, and if they do not work, then you know that you can kind of adjust one way or the other. But if it does work, then answer C, you answer it and move on. Like I said, there's 5 answer choices here. So, you know, 20% of your answers are going to either be A or F, 20% will either be B or G, 20% will be C or H, 20% will be D or J, 20% will be E or K. Okay, so you can that kind of helps you. But remember, pick your letter of the day and consistently guess with the same, you know, letter combination, either A, F, B, G, whatever. Because statistically it's going to come out better when you're guessing. All right. So here's some tips for trying answers. If the answer choices are a mix of integers and fractions, it's going to be easier to start with integers. Okay, so plugging in answers, it's going to be a whole lot easier to plug in an answer that's a whole number or that's an integer versus a fraction. If the question asks for a minimum or a maximum value, it's better to start with the minimum number or the maximum number. So if it says the minimum value is this, then start with the smallest number option. If it says the maximum is this, start with the maximum. Trying answers can take more time, so you do not have time to try all 5. Okay, so for questions that are easier that you can solve quickly, it's better to work the problem in the booklet and solve than trying the answers. Okay. So what you'll have to do is, again, you only figure these things out by doing practice tests. The next thing is organizing information given in the problem. So when you're given information in the problem, go ahead, and it may be that you have to write an equation. It may be that drawing a picture, that drawing a chart or a graph, or making a list, or doing something to help you organize the question can be helpful. You stand in numbers for variables. So sometimes you can go ahead, and if it has a situation, we'll look at an example in just a minute, you can just say, hey, I'm going to let A equal this and B equal this, and use those as your stand-in questions. And it says this strategy works when you have variables in the question and some of the same variables are answer choices. So if we look at this example right here, where it says consider the following. If A and B are positive consecutive odd integers. Okay, so again, as you're reading this, you're thinking positive, you know, that, you know, obviously they're not negatives. Consecutive odd integers. So then you start thinking about consecutive means they go in order and they're odds. So 1, 3, 5, 7, 9, you know, consecutive odd integers, where b is greater than a, which of the following is equal to b squared minus a? So we have the information that we're given both a and b are consecutive odd and that b is greater than a. I can see here I've got variables in my problem. I have variables in my answer. So by picking 2 consecutive odd numbers, I can plug it into this equation and test it really quick. So here we picked the numbers, a is 3, b is 5. So if I looked at this and just said, hey, since I know b squared minus a squared, so if I said 5 squared minus 3 squared, that means 25 minus 9. And I know that that's equal to 16. Okay. So when I'm looking at my answer choices, I'm looking at what times something would give me an answer of 16. So when I look at answer choice A, and I plug in the value that I used for A, 2 times 3 is only 6. That doesn't work. If I did 4A, that means 4 times 3 is 12. That doesn't work, so I need to eliminate that. 2A plus 2. 2 times 3 is 6, plus 2 is 8. Eliminate that one. 2A plus 4. 2 times 3 is 6, plus 4 is 10. 4A plus 4, I plug in the value of 3. 4 times 3 is 12, plus 4 is 16. So I can see that that is my correct answer choice. Okay, by just coming up with any 2 numbers, then I'm able to do that. And again, it doesn't matter if I would have chosen to use 5 and 7. Let's look at what that would be. If I said A was 5 and B was 7, again, I would have 7 squared minus 5 squared. So I'd have 49 minus 25 is equal to, let me get my calculator. 45 minus 25 is 20. So again, when I'm plugging in my numbers over here, instead of trying to get 16, I'm trying to get to 20. So again, what did I do?
Are you sure it's 20?
Yeah, that's not, well, it would be 20 if I typed in the right numbers on my calculator. I did 45 minus 25. 49 minus 25 is 24. That's why it didn't work. I was going, whoa, wait a minute. 24. So again, when I plug it into this equation here, and I have 4 times 5 is 20 plus 4 is 24. Okay, so no matter what 2 choices I pick, when I plug in the values, it's going to work there. So if you just choose things that meet the criteria of what your directions tell you to use, you can plug in or you can substitute numbers for variables. You can use those stand-in numbers to see what it would be. Again, depending on what my answer choices are, you know, again, those are things that you could pop in your head real quick. You wouldn't even have to write this out, okay? You could do that in your head and then plug in, substitute your answers, okay? This next one, simplify the question. So it just says that, sorry, get all this off so I can see where I am again. Okay. Simplify the question. Some ACT questions appear quite difficult at first glance, but after careful review, turn out to be pretty straightforward questions. They often include formulas, equations, etc., and ask you to solve for a variable. Sometimes they'll look really confusing, but if you look at it, take it step by step and try to simplify it instead of trying to look at it as a whole, look at it piece by piece and try to simplify that. Again, would be something maybe numbers that have a whole bunch of zeros on it, and you know that you're going to be dividing, and you could just go ahead and cancel some of those zeros. Instead of doing division with a big number, you're able to simplify it to a smaller number, but simplify it as much as you can. We'll be looking at some examples of all these later too as well. All righty, let's look at our time real quick. So let's go ahead and take our 5-minute break. And then I've got 11:11, so we'll come back about 11:16, 11:17. So take a minute. Okay, everybody ready? All right, so starting on our necessary skills for ACT math. Okay, so we said the first scoring area was number and quantity. So we're going to kind of take this apart and look at to see what kinds of questions or what type of material is being assessed in this section. And the first one is real and complex number systems. So think about real numbers. If you had me for Algebra 1, you know that we started out with our little diagram and we drew the pictures of the boxes and we talked about real numbers. We talked about how natural numbers are counting numbers. They were the first numbers that you learned when you were little and you learned to count. So natural numbers, then you have whole numbers. Whole numbers are those natural numbers and the number 0 added to it. Then we have integers. Remember, integers are positive and negative whole numbers that are on the number line. We think about integers. We talked about how after integers, we have what are called rational numbers. And remember, rational numbers are numbers that can be expressed as a fraction. They're also going to be decimals that either terminate or they repeat, okay? And then we have irrational numbers, which are non-terminating, non-repeating decimals, and then imperfect squares. These are going to be all natural numbers that are not perfect squares. So that's what we have listed here about rational numbers and irrational numbers. So those are our real numbers. Then we have non-real numbers, okay? And so these are things that we've talked about before, but we've never really learned about them. The first non-real number is any number divided by 0. Remember, division by 0 is not defined. It is not, we cannot divide by 0. So that's why we call that a non-real number. The square root of a negative number. Remember, we talked about how square roots are always radicals are always going to have to be positive numbers because a number times itself. If I have -3 times -3, that makes a +9. If I have 3 times 3, that's a +9. So when I have square roots, I know that a square root cannot be negative. So that is what we call an imaginary number. We're going to talk about imaginary numbers in a little bit. We'll go into that in a little more detail in a minute. And I think you will find that, you know, you hear imaginary numbers and you go, oh my goodness, that's going to be so complicated and hard. It's really not that bad. If you've had Algebra 2, maybe you've dealt with some imaginary numbers, but maybe you either haven't seen them or you don't remember, but we'll go over those. Alrighty, the next one, number line and absolute value. The number line represents the spectrum of all real numbers, rational and irrational. So typically when we were in Algebra 1, we only dealt with integers on the number line. So we only dealt with positive and negative whole numbers. But now that we're going a little bit further, we're looking at how all of these things do fit on the number line. So you can see we've got the number line here from, you know, -5 to +5, but remember the arrows on the end mean that it's extending indefinitely in both directions, okay? You can see also that where a decimal would fall, if we had the decimal -1.5, we know that's going to come between -1 and -2. A fraction of 1/3 we know is going to be between 0 and 1, but it's going to be closer to 0 than 1. The square root of 2, you can see where it's placed on the number line. Pi, 3.14, da 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 da. We know that that's going to be closer to 3 than 4, but it kind of helps us to see that all of these numbers can be placed on the number line somewhere based on their value. Okay, now absolute value, remember we talked about how absolute value is the number's distance from 0 on a number line. And remember that distance cannot be negative, therefore absolute values are always positive. My absolute value symbols are going to be those lines. And remember that the absolute value of 5 would be a +5. The absolute value of a -5 is also a +5 because whether it's 5 or -5, it is 5 places from 0 on the number line. The only time that you're going to be dealing with the absolute value and a possible negative solution is when you have that negative sign in front of the absolute value, and that is read as the opposite of or the negative of, okay? So when I look at that, that's either going to be the opposite of the absolute value of 5 or the negative of the absolute value of 5, and that would give me an absolute value and give me an answer of -5. Likewise, if I have the opposite of the absolute value of -5, that's also going to be -5. The first thing I would do is look at my absolute value and then take the opposite of it. Okay, so the opposite of a positive is always going to be a negative. So those answers will be negative. That should be just a review of things that you already know. Remember that as we're going through these things, if you have any questions about any of them, please be sure to let me know. Multiples, factors, and prime numbers. We know that multiples are when I multiply numbers together. So basically, if you want to think about your times tables as multiples, 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, so on and so forth. Those are multiples when I've multiplied 2 positive whole numbers together. Remember, factors are going to be those numbers that multiply together to make a multiple, or a factor is a number that divides evenly into a number without a remainder. Okay, so my factors of 25 would be 5 times 5. All right, prime numbers, numbers that only have 2 factors, one in itself. A composite number is going to be every other number that has factors other than one in itself. And when we do prime factorization, that's the process of factoring a number into only prime factors, okay? So I've got a little practice here. So we're going to practice finding the prime factorization of the following numbers. If I'm looking at my prime factors of 20, okay? My smallest prime factor is 2, so that's always where I start. So I think about 2 times what is 20? And I know that would be 2 times 10. So now I've got to do prime factorization of 10. My smallest prime factor of 10 is also 2. And that's going to be 2 times 5. 5 is a prime factor, so there's my prime factorization of 20. I could also list this as 2 squared times 5. Okay? So remember, when you list prime factors, all factors have to be prime. I can check it to make sure I've gotten the right one by just multiplying them together. 2 times 2 is 4, 4 times 5 is 20, so I know I have my prime factorization. I can express it with exponents. Looking at 36, smallest prime factor of 36, again, is going to be 2. 2 times 18 is 36, so now I need to break down 18. Smallest prime factor of 18 is going to be 2 as well. That's going to be 2 times 9. Smallest prime factor of 9 is 3, and that's 3 times 3. So again, I can express this as 2 squared times 3 squared. Again, I could multiply together to make sure I've got the right thing. 2 squared is 4, 3 squared is 9, and 4 times 9 is 36. So I know that I'm good. 48, same things. That's going to be 2 times 24. 24 will be 2 times 12. 12 is going to be 2 times 6, and 6 will be 2 times 3. So I've got 2 to the 4th times 3 as my prime factorization here. Okay, so prime factorization is listing all prime factors to represent a larger number. Decimals and percents. A decimal represents a fraction with a denominator that's a multiple of 10. So if I have 0.3, that's the same as 3/10. If I have 0.03, that's the same as 3/100. If I have 0.003, that's the same as 3 over 1,000. And I could keep going on from there, but I think you get the gist. Okay. A percent represents the fraction of a number over 100. For example, 35% is the same as 35 over 100, which could be written in decimal form as 0.35. I have directions here on how to convert a decimal to a percent. You're going to multiply the decimal by 100 and place a percent sign at the end. So if I had a decimal of 0.26, I would multiply that by 100. That would be 26, and I'd put my decimal on the end. 4.12 times 100 would give me 412, and I'd put my percent sign on the end. To go from fraction to a percent, the first thing I would have to do is I've got to divide my numerator by denominator. Okay, so in my example here, 4 divided by 25 would be 0.16. Multiply that by 100, which is 16, and put my percent sign on the end. 45 over 75, I would divide 45 by 75, that's 0.6. Multiply by 100, that gives me 60, put my percent sign on the end. Okay. All right, let's look at this practice. I need to convert the decimals to percents. I have 0.98. What is that going to equal as a percent? I would multiply 0.98 by 100. That's going to give me 98. And I just add my percent sign on there. Remember, that's the same as moving your decimal over 2 places. So if I just want to go with that, move my decimal 2 places, this is 285%. Move my decimal over 2 places is the same as multiplying by 100, so this will be 5%. Now converting fractions to percents, the first thing I would have to do is divide 7 by 14. Well, I also know that 7 over 14 is equal to 1/2, and I know that 1/2 is equal to 0.5. So 0.5, I'd have to move my decimal over 2 places, so that would be 50%. 15 over 80, I would divide. 15 divided by 80 equals 0.1875. Again, to multiply by 100 means I'd move my decimal 2 places to the right, so I have 18.75 and add my percent sign. 212 divided by 50 equals 4.24. Move my decimal 2 places to the right. That's the same as multiplying by 100, so I end up with 424%. If these are skills that you do not remember, then it's going to be a good time for you to review, to go back, look through how to do these things. Percent of change. To find percent of change, determine the amount of change by finding the difference of the original amount and the new amount. So remember, finding the difference means I'm going to subtract. So I subtract my amounts. I write the beginning amount in the denominator and my new amount, my change in the numerator. Convert to a fraction, then to a decimal, then to a percent. So let's look at this example. It says find the percent of change for the dress that was originally 75 and then mark down to 45. So the first thing I did was find the difference, and I found that 75 minus 45 is 30. 30 goes in the numerator. 75 was my original amount, so that goes in my denominator. So now I have 30 over 75. Now I've got to convert that to a decimal and then to a percent. So to convert to a decimal, I divide 35 by 75, so that's 0.4. Then I have to change 0.4 to a percent by multiplying by 100 and placing my percent at the end, so I have a 40% change. It says notice percent of change is always positive, so even if the new amount is less than the original amount, I'm not ever going to have a negative. So if it went from 45 to 75, I wouldn't have a negative 30. Okay, I'm just going to find the difference by taking the larger amount minus the smaller amount. So what we're going to do here is we've got some practice to find the percent change. Okay. So going from 5 to 3, what is our change amount? I know the difference of 5 and 3 is going to be 2. So that's my numerator. My denominator is my original amount. Okay. So this is my difference. This is my original amount. Okay, so now I have 2/5. So now I'm going to have to divide 2 by 5. Okay, so 2 divided by 5 is 0.4. Multiply by 100, so that's going to give me 40. Put my percent sign on the end. For the next one, again, I find my difference from 55 to 66. My difference is going to be 16. My original amount was 50. So I'm dividing 16 by 50. That gives me 0.32. Change my decimal to a percent by multiplying by 100, so that's 32%. Going from 20 to 70. I know my difference there is going to be 50. My original amount was 20. 50 divided by 20 equals 2.5. I have to change from my decimal to a percent. By multiplying by 100, that means I move my decimal 2 places to the right, so that's going to be 250% change. So find the difference. That goes in the numerator. The original amount goes in the denominator. Then you're going to change from a fraction to a decimal to a percent. Is everybody good with that?
Yes, ma'am.
Next.
I'm going to use, may I use the bathroom real quickly?
Oh, sure, go right ahead. The next one is a percent of a group. Okay, so if we're talking about the percent of a group, I'm going to take the number of the subgroup that I'm looking at, and that becomes the numerator. So my subgroup over the value of the entire group. So if I have 7 of 20 job applicants having a college degree, then I'm going to write that as 7 over 20. Okay, so my subgroup over the entire group, again, change my fraction to a decimal, decimal to a percent. So if we practice with that, if we said 6 of the 25 dogs are labs, that means I'm going to write 6 over 25. 6 divided by 25 is 0.24. So that is going to be 24%. 170 out of 200 flights are on time. So that's going to be 170 over 200. I divide 170 divided by 200. That's 0.85. Decimal to a percent, 85%. 28 out of 40 cars are electric. Put 28 over 40. 28 divided by 40 equals 0.7. So that will be 70%. Okay, so percent of group, you just put your subgroup over the total group, divide, convert to a percent. Fractions and ratios. A fraction is a numerical quantity that represents a value that is going to be less than 1. The reciprocal of a fraction is where the numerator and denominator switch places or flips. Okay, so if my fraction is 3/4, its reciprocal is 4/3. If my fraction is -3/5, the reciprocal is -5/3. Okay. Adding and subtracting fractions, remember you have to find common denominators before you can add or subtract. So if I have 5/8 plus 3/4, I have a common denominator of 8. So 5/8 stays the same, but 3/4 becomes 6 over 8, which equals 11 over 8. Multiplying fractions, you multiply numerator by numerator, denominator by denominator. Dividing fractions, remember we have to change from division to multiplication. We do keep, change, flip. We keep the first fraction. We change our sign from division to multiplication, and then we flip it or take the reciprocal of the second fraction and then multiply. Okay? Remember that anytime you are dealing with fractions, the ACT, the answers are always going to be in simplest form. So you've got to remember to reduce your fractions, find simplest form, or you're going to be confused why your answer does not match any of the answer choices, that they're always going to be reduced. Same thing with ratios. Ratios I can express as a fraction, or I can use my colon in between my first and second number. So it says a ratio compares the quantities of two groups as a reduced fraction and can be written with a colon in between. So my example is a sports gym has 24 baseballs and 16 footballs, and we want to express that as a ratio. I'm going to take my baseballs, compare them to footballs. So I put my value of baseballs in my numerator, footballs in the denominator. I can reduce that to 3/2, or I can write that as 3:2, okay? So again, 3:2, I would leave that as an improper fraction, but it is reduced, or I can write it with a colon in between instead of my fraction bar. For the actual quantity of a given ratio, when you know the total quantity. So if instead of it saying I've got, you know, this many of this thing and this many of this thing, find the ratio, maybe it says this is my ratio, I have a total of this, so what are my quantities? So the example of this one would be if it says, if the ratio of gloves to bats was 2:3, and there were a total of 30 gloves and bats, how many of each were there? So I've got to look at this, and I know that my ratio is 2:3. So I'm going to let my actual number be a variable. So I know that I have 2x gloves and 3x bats. Add those together. 2x plus 3x is 5x. I know that it equals a total of 30. So then I solve for x, and I find that x is 6. So then I can substitute that in. So when I substitute in 2x is 2 times 6, I find that I've got 12 gloves. 3x is going to be 3 times 6, and I have 18 bats. Okay? So we're going to practice with this. The first thing is there were 15 cars and 35 trucks. What was the ratio of cars to trucks? If I'm just looking at a simple ratio, I'm going to put my first number in the numerator, my second number in the denominator, but then I need to simplify. 15 divided by 3 and divided by 5 is 3. 35 divided by 5 is 7. So that would be 3 to 7, or I could write it as 3:7. Looking at the ratio of classical to electric guitars, it's 3/4. There's a total of 35 guitars. So I'm going to set up an equation where I say 3x plus 4x equals 35. So I know 7x, 7x equals 35, so x equals 5. I can plug in 3 times 5 is 15, so I know that's how many classical guitars I have. And then 4 times 5 is 20, so I know that's how many electric I have. Again, I can always look, and 15 and 20 equals 35, so I know I found the right thing. So if I know my 2 bits of information, I just set it up as a fraction to represent a ratio. If I know my ratio and my total number, I have to set up an equation. My coefficient is going to be based on my ratio. So I set up 3x and then 4x based on my numbers and my ratio. I set them equal to the total number, solve for x, and then plug them in to find how much of each thing. Okay? Exponents. We know that exponents are bases with a little number that's called a superscript. It's that little number that's in the top right corner. And so we know that whatever the exponent is means that I'm going to multiply the base by itself that many times. So 6 squared means it will be 6 times 6, which is 36. 6 cubed will be 6 times 6 times 6, which would be 216. Now, I think we're pretty good with those, but now we have to think about negative exponents, okay? So if you have a negative exponent, you have to make it positive. Negative exponent, you must make positive by taking the reciprocal. Then you keep the exponent with the number it was originally with. So if I have 6 to the negative second, I take the reciprocal, which is 1 over 6, keep my exponent of 2 with 6, so that becomes 1 over 36. If I started with my negative exponent in my denominator, again, I'm going to flip it. So now I have 6 to the second over 1. I know 6 to the second over the 1 is the same as just 6 to the second, or 6 squared, and 6 squared is 36. So depending on where my negative exponent starts, I'm going to flip to make it positive. Okay, so if it's negative to begin with and I flip it, it may become a fraction. It may start as a fraction and end up as a whole number. It just depends on what your exponent is and depending on what your fraction starts out as. Multiplying and dividing exponents. We know that if we are multiplying exponents, I will add. If I'm multiplying exponential expressions, I add the exponents and I subtract when I divide. So if we look at x to the second times x to the third, I know that means I would add 2 plus 3, and that's 5. If I'm dividing x to the 7th divided by x to the 4th, I subtract 7 minus 4, and that gives me 3. When I multiply, I add the exponents. When I divide, I subtract. So let's look at this practice. If I have x to the 5th times x to the 4th, I'm going to end up with x to the 9th. If I have x squared times x to the negative 5th, again, I'm going to add 2 plus a negative 5. Okay, so again, I'm doing 2 plus negative 5. That's going to give me negative 3, so I'm going to have x to the negative 3rd power. Now, if my direction said to express all powers positively, then for my final answer, I'm going to have 1 over x to the 3rd to express that as a positive exponent. Okay. And then 8 over 2, evidently I forgot my exponent, I guess. What in the world did I do? So let's go ahead and give it an exponent. If it's outside parentheses, let's make it negative. If it's outside parentheses, I know it has to apply to both. So that means I'm going to have 2 squared over 8 squared, which is going to be 4 over 64. And then I could simplify that, or I'll go into 64 16 times, so I'd have 1 over 16 on that. I know we're kind of scooting through all of this. Again, it's the kind of thing where if you find that these are any skills that you go, ooh, I don't remember that, you're going to need to go back and study these, okay? All right, when you have an exponent of an exponent, okay, so it's when I have an exponent outside parentheses, I go ahead and I multiply those. So x cubed raised to the 4th power, I multiply 3 times 4, and that's 12. So in this one, if I look at x squared raised to the 5th power, I know I'm going to multiply 2 times 5 is 10. Same thing here, y to the 4th raised to the negative 3rd power. 4 times negative 3 is going to give me negative 12. So if I have to show that as a positive, I'm going to need to go ahead and make that 1 over y to the 12th. I need to take the reciprocal, keep the exponent with what it started with. So same thing here. If I have z to the negative 1st to the negative 2nd power, negative 1 times a negative 2 is a positive 2. So I'm going to end up with z squared, because negative 1 times a negative 2 equals a positive 2. Okay. Multiplying, add the exponents. Dividing, subtract the exponents. If you have an exponent raised to an exponent, you multiply the exponents. All righty. Here are some variations of exponents that you might possibly see. -4 squared means I have -4 times -4, so I'm going to end up with a positive 16. If I have no parentheses, this is read as the opposite of 5 squared. Well, 5 squared is 25. So the opposite of 25 would be -25. Okay, so another way I can look at that would be the opposite of 5 squared, which equals -25. If it's in parentheses, I multiply negative times negative. If it's outside of parentheses, I take the opposite of the number squared. So that is why it would be negative. Okay, 3 to the -2nd power again. I'm going to have my reciprocal, put my exponent with the number it was originally with. 2 to the 5th raised to the 2nd power means I'd have 2 squared over 5 squared. So again, that would be 4 over 25. This one may be simplified to 1 over 9. 0.4 squared means I have 0.4 times 0.4, which is going to be 0.16. Now look at x plus 2 squared. This does not mean I'm going to have x squared plus 2 squared. This means I have x plus 2 times x plus 2. How do I multiply polynomials? What do I use to multiply polynomials? Does anybody remember? Remember FOIL? First, outer, inner, last. Okay, so that means I have to multiply my first terms, which is x times x, which is x squared. I multiply my outer terms, which is x times 2, so that's 2x. I multiply my inner terms, which is 2 times x, which is also 2x. And then I multiply my last terms, which are 2 times 2, which is 4. Combine my like terms, which are those middle terms. So I have x squared plus 4x plus 4. Okay, be real careful when you've got multiple terms raised to a power. If I have a variable and a number, I'm going to have to FOIL it. 6 to the 0, any number raised to the 0 power is 1. Then if I have x cubed times x to the -3rd, remember this would be the same as x to the 3rd plus a -3. So that gives me x to the 0, which again is going to equal 1. All right, imaginary and complex numbers. Again, before I sat down working on this yesterday, this was either stuff that I don't remember learning, or if I learned it, I have long forgotten it. Imaginary and complex numbers. Okay, imaginary numbers are represented by the lowercase letter I. And I is equal to the square root of -1. Remember we talked about I can't have a negative radicand underneath that sign. That's what makes this an imaginary number. So if I is equal to the square root of -1, then that means I squared is equal to -1. Okay, so for imaginary numbers, I just need to remember this, where I is equal to the square root of -1, or I can look at I squared and that's -1. Because a square root cannot be a negative number, it's called an imaginary number. Imaginary numbers can be simplified using the following process. So if I have the square root of -25, I am going to break that into the square root of 25 times the square root of -1. Remember how we learned previously where if I'm multiplying radicals, I can just combine them under the same radical sign? Same thing is, I can take them apart. So I can break this into the square root of 25 times the square root of -1. Well, we just learned that I is equal to the square root of 1. the square root of negative 1. I know that the square root of 25 is 5. So now I have 5 times I, which is 5I. I took the square root of 25, which is 5. I've just learned that the square root of negative 1, I can substitute the symbol on the letter I. So 5I is the simplified form of that. Okay, so let's look at some practice of that. If I have negative 9, the square root of negative 9, then I can just look at that and say, hey, the square root of positive 9 is 3. And then I would have the square root of 9 times the square root of negative 1. And we learned that the square root of negative 1 is I. So I'd have 3I. Same thing with negative 36. That's the same as the square root of 36 times the square root of negative 1. So that's going to be 6I. It seems really confusing and complicated at first, but when you look at it, you go, okay, that's not a big deal. Now this one, the square root of negative 5 would be the square root of 5 times the square root of negative 1. So I could just simplify that as the square root of 5I. Since the square root of 5 I cannot simplify, I'm just going to leave it as that, but I just put it with the I. Any questions about that? So again, dealing with imaginary numbers. I know that I squared is equal to negative 1. Actually, I'm just going to highlight that. So if I squared equals negative 1, and I have 3I squared, that means I have 3I times 3I. I multiply 3 times 3, which is 9. And then I times I, remember that's going to be I squared. And we just said that I squared is equal to negative 1. So if 3 times 3 is 9, and I squared is negative 1, then I can multiply that together and get negative 9. So here, same thing. If I have 5I times 5I, I can look at that as 5 times 5 times, I times I. 5 times 5 is 25. I squared is negative 1. So 25 times negative 1 is negative 25. So basically, all I have to do is list them out as numbers times each other. Let's look at this next one. I've got 2I to the 4th. So that means I have 2I times 2I times 2I times 2I. Okay? So that means I have 2 times 2 times 2 times 2. And then I have I times I times I times I. 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. But notice now I have 16 I squared times I squared. Remember, if I squared is negative 1 and I squared is negative 1, what is negative 1 times negative 1? It's going to be a positive 1, right? So that means I've got 16 times 1, so that will give me a positive 16. Two I cubed means I've got 2I times 2I times 2I. 2 times 2 times 2 times I times I times I. I know that 2 times 2 times 2, 2 times 2 is 4, 4 times 2 is 8. Now here, I have got I squared times I. I squared is going to be -1. So I have 8 times -1 would be -8, but then I also have an extra I that can't be paired up to make a -1. So I have -8I. (3i) times 5i is going to be 15i squared. We know that I squared is equal to -1, so that's going to be 15 times a -1, so that's going to equal -15. 2i times -3i. 2 times -3 is going to be -6. I times I is psi squared. Remember, I squared is -1, so -6 times -1 is +6. Again, something that is as much information as we're kind of cramming in now, this will be good for you to go back and look at and make sure you understand. Or you say, hey, this is going to be one of those things that for now I'm guessing on. Okay? All right, so those are imaginary numbers. Remember, imaginary numbers, we're going to let I squared equal -1. Or the square root, I is equal to the square root of -1. So this right here, we need to remember. That's one of those memorization things that you need to know. Imaginary numbers, I equals the square root of -1, or I squared equals -1. Then apply those, substitute those values in when you need to. The next one is complex numbers. A complex numbers includes the imaginary I in the form of A plus B times I, okay? So if I knew what A and B were, I could plug those in. So this example they've given me is 3 plus 2I. Says complex numbers can be represented as a graph on a number plane where our horizontal axis is labeled R. Let's move to the next page. And that represents the real component, and the vertical axis labeled I represents the imaginary component. To represent the complex number 3 plus 2I, you plot 3 places to the right of the origin and 2 places up, and so we can see that we can actually express 3 plus 2I as the ordered pair 3, 2 on my graph. Because we went right 3 places and up 2. Okay, this is dealing with complex numbers, which is an imaginary number, and we're putting it on a graph. We can also use the distance and midpoint formulas with complex numbers. Okay, the main thing that is different is that we have, when we do the distance formula, we're using A and B as the coordinates of one point, and S and T are the coordinates of the other point. So instead of using X and Y, we're using AB and S and T. Okay, so for the distance between 3 plus 2I and -5 minus 4I, notice that 3 plus 2I is going to be the ordered pair 3, 2. -5 minus 4I becomes the ordered pair of -5, -4. Then I just use my distance formula, which is distance is equal to the square root of S minus A squared plus T minus B squared. I plug in my values of my ordered pairs that they've given me. So if I plug in -5 for S, 3 for A, -4 for T, and 2 for B. It's distance formula exactly like we did at the end of last year in Algebra 1, or if you've done geometry, you'll use the distance formula also. But we're just renaming X and Y And we're using the ordered pairs for my imaginary numbers or my complex numbers. When I plug those in, I perform the calculations, and -5 minus 3 would be -8. -8 squared is 64. -4 minus 2 is going to be -6, and -6 squared is a positive 36. 64 plus 36 is 100. Whoops. And so, D equals the square root of 100, so D is equal to 10. Midpoint, I'm doing the same thing, okay, except for my formula is different. I know that I add, basically when I'm doing midpoint, I add X and Y, I add my X coordinates and divide by 2, and I add my Y coordinates and divide by 2. In this situation, I'm using A, B, S, and T. I add A and S, divide by 2. I add B and T, divide by 2, but then I have to multiply that by I. So when I plug in my values, using those same values, 3 plus -5 is -2. 2 plus -4 is -2. So I can see where I have been able to simplify. -2 divided by 2 is a -1. Again, -2 divided by 2 is a -1. So I have -1 plus -1 times I. So I can simplify that by looking at the plus and negative becomes a minus. And so I have -1 minus I. Phew. Imaginary and complex numbers. If this is new to you, go back and look at it later. Multiplying or squaring complex numbers. Again, remember, if I have 3 plus 2i squared, that means I've got to multiply. Uh-oh, I think I lost Megan. Or did my screen just change? So that means I've got 3 plus 2i squared. That means I have to multiply 3 plus 2i times 3 plus 2i. I have to FOIL it. First, 3 times 3 is 9. Outer, 3 times 2i. Inner, 3 times 2i, which is 6i. And then last, 2i times 2i is 4i squared. Remember that I squared is equal to -1. So when I do 4 times -1, that's going to equal -4. Oh, she said her laptop died. Let's see. And actually it is 12:05, so we are done for the day. What we will do is we will start off. What I would like you to do for homework is I want you to review our imaginary and complex numbers. I want you to read through this section, multiplying or squaring complex numbers. Do this practice right here. If you have not already done a practice math test, I need you to do that, to score it, and to start looking at why you missed what you missed, okay? Next week, we will pick up with vectors, and I'll have another packet to give you when we're in class next week, okay? I know it was a lot of information I kind of threw at you today, so go back and reread. If you're confused about anything, let me know if you have questions about anything, and I look forward to seeing y'all in class next week. So homework is to finish up this section on multiplying or squaring complex numbers, and then if you haven't done your practice math test, get that done, score it, and then look at why you missed what you missed, okay? I hope y'all have a great afternoon and rest of the week, and I will see y'all next week.
Bye.
All right. Bye, y'all. Bye-bye.